regression lines. The least squares regression line is the full name given to the regression line, and it represents this, where the sum of the squares of the residuals has its least value. So let's investigate what this means. So here's a scatter graph, regression line. You can get the equation of that from your calculator. This is called a residual. It's the vertical distance between an actual point on your scatter graph and the regression line, that distance there, the vertical distance. So this is just one residual. Every single point leads to a residual, and we square those residual values, and then we sum them up, we add them together, like r1 squared plus r2 squared and so on. And that can be represented by the sum of all of the residual values squared, sigma r squared. And this sigma r squared has its least value for this regression line. So the regression line of y on x is a straight line that minimizes the value of sigma r squared. Hence it's called the least squares regression line of y on x. That's the full name given to this line. We typically just shorten that to the regression line. Here is an example of a scatter graph, and you've got points here, and these vertical lines represent the residuals, and if you square all of the residuals and add them together, you get this value. So at the moment, for the line in this position, the sum of the squares of the residuals is 14.85. But is that the minimum value possible for sigma r squared? So what I'm going to do is I'm going to move the line around, and you can see the value of sigma r squared changes for different positions of the line. The line is pivoted around this point, the mean point. So the lowest value I can achieve is about here. So this would now be called the least squares regression line of y on x, where the sum of the squares of the residuals has its least value. Now once you've worked out your regression line equation, you can use the equation to estimate. So when estimating, so here's an example, h against w. So starting with a student's weight, we can estimate height. Here's an example of w against h. So starting with a given height, we can estimate a student's weight. For a reliable estimate, you want to be working within the range of your data, so interpolation, and a strong PMCC is desirable, strong correlation. If you go outside the range of your data, so when you're extrapolating, that generally leads to unreliable estimates. A weak correlation will also lead to an unreliable estimate. So interpolation is good, but not extrapolation. But there are varying degrees of extrapolation. So my data actually goes between here and here. This is the range of my given data values. But if I'm a little bit outside that range, so if I'm estimating at this point, for instance, the estimate would still be okay, it's still reliable. But the further you go away from your data, the more unreliable your estimates become. This linear relationship that we see here in this interval may not continue outside the interval. For all we know, the data does this afterwards, it levels off, and this linear relationship does not continue outside that range.